All right, looking at a little circular motion here. Circular motion is basically a formula that we're going to use to describe how things move in circles, okay? Lots of different things, obviously, in real life using circles. Wheels and gears and Ferris wheels and pulleys and so many things move in circles. And so we need to kind of have a method to our madness when working with formulas and making predictions based on circles, okay? So we played a little crack the whip in class. Hopefully you kind of understood a little bit about what that meant and where we were headed. But when you're dealing with circular motion, there's first of all this formula right here, this V equals RW that you're going to use all the time. V stands for linear speed, W stands for angular speed, and R is your radius. Okay? So V is your linear speed. It will always be given to you in a distance per time. It's the miles per hour kind of speed. Miles per hour, inches per second, centimeters per minute, those kinds of units. But a distance and a time is your linear speed, okay? It's how fast you're moving around the outside edge of the circle. All right, then there's angular speed, which is your W. And angular speed will be either given to you in degrees or revolutions or radians per time. So it might say degrees per minute, it might say revolutions per day, it might say radians per hour, whatever. But it needs to be in radians. So if it's not in radians per time, it has to be converted to radians per time. And we'll talk about that in a minute. The hard part to doing circular motion is that they will never ever say directly in a problem, the linear speed is this and the radius is this. Now you find the angular speed. It won't happen like that. It'll give you some information and you're going to need to decipher out of that information what it gave you, okay? You're always going to use this formula, V equals RW, and you will always know two of the three parts, but it won't directly tell you which parts you have. And so once you get that deciphered, that's kind of the worst part of it. And when you can figure out whether you have the linear speed or the angular speed or what you have, it will make it easier, okay? So we're going to do two problems. These take just a little bit because I'm going to go nice and slow and hope that you understand them. All right, so the first problem talks about a merry-go-round, a carousel, and the radius of that carousel is 25 feet. And you can think of horse A sitting at the edge of the carousel. All right, so horse A is out here at the edge. We'll call this horse A right here, okay? The radius is 25 feet, so to the center it is 25 feet. And horse B is 2/3 of that distance, so horse B is sitting in the inside a little bit more from the center to the edge. The disc or the circle, the bottom part of the merry-go-round or the carousel, revolves 25 times every 8 minutes. Okay, so hopefully this part is pretty clear. This is your radius, obviously. We know that. At least for the outside horse, the radius is 25 feet. Okay. For the inside horse, we'll have to do something a little bit different. But we need to find the angular velocity and the linear velocity. Okay? We know that the angular velocity is our W, and the linear velocity is our V. Just so you know that. And it doesn't directly tell me, but it gives me one of those for the horses. And when it says that it revolves 25 times every 8 minutes, in other words, it makes 25 revolutions every 8 minutes. Revolutions and time. Revolutions is not a distance. Distance would be like centimeters per time or feet or miles or whatever. But revolutions is not a distance, okay? Revolutions is referring to an angle. And when it's referring to an angular angle, then that's your angular speed, okay? So let's talk about horse A first. So horse A's angular speed is 25 revolutions every 8 minutes. Okay, that's the angular speed. Now the problem is when I'm going to use that horse's angular speed in the formula, it has to be in radians, okay? It has to be in radians. So you're going to need to convert that revolutions to radians, and one revolution is one trip around the circle. So one trip around the circle, we know, is 2 pi radians. So if you have not had a little chemistry here, here's your little chemistry lesson. When you do this, we know that I'm going to do this off to the side, one revolution is 2 pi radians. Okay, one of those units is going to go on the top of the fraction and one of the units is going to go on the bottom of the fraction, one of those two units. What you want is the same units to be kitty corner from each other. So I want one revolution to be kitty corner from a revolution. These two right here, same units are kitty corner from each other so that those units drop out. So one revolution is the same as 2 pi radians. Okay, my revolutions are kitty corner from each other, so now these are going to drop out like that. Okay, and then I can reduce this. Okay, so you can get an exact answer, that's fine, or you can get a decimal answer. And if you get an exact answer, what you're going to do on your calculator is you're going to ignore the pi for right now, and you'll just take 25 times 2 divided by 8, hit math, enter, enter, and then it should reduce for you, and then throw the pi back in. Okay, and when you do that, you should get 25 pi over 4, and now you'll be in radians per minute. Okay, I don't know what the decimal value is, but if you get the decimal value, you just take 25 times pi divided by 4. And we could go from there. Okay, then let's think about what else we know. Okay, I can then figure out the linear speed for horse A if I want to. And in order to figure out the linear speed, I'm going to use the formula V equals R times W. Okay, for horse A, the radius is 25 feet. And my W, I'm going to carry from right over here. That's where I'm getting my W. And that will be 25 pi over 4 radians per minute. Okay. When I multiply that out, again, I'm going to ignore the pi, and I'm going to take 25 times 25 divided by 4, hit math, enter, enter, and reduce it. When I do, and then throw the pi back in, when I do that, I should get 625 pi over 4, and you need to think about units here. Nothing's canceling, and it looks like it will be feet radians per minute, because I have feet here, I have radians here, I have minutes here. Feet radians per minute. That doesn't make any sense, okay? Again, radians are that magical unit that will appear and disappear when you need them to. So radians is going to disappear, and your linear speed in this case will be in feet per minute, okay? And again, linear speed is always in a distance per time, so feet per minute would be in a distance per time kind of unit. And that's how that goes. Okay, now we're going to move on to horse B, and we're going to think about, is anything different for horse B, or are things the same for horse B? Okay, so for horse B, the horse still is sitting on the same carousel. Okay, it's still sitting on the same circle, and so because it's on the same circle, it's still going to rotate 25 revolutions every 8 minutes. Okay, so it is on the same circle and rotating at the same speed. So it's on the same circle, so I'm going to write this, same as horse A. Okay, so because it's the same as horse A, it is still going to rotate at 25 pi over 4. And again, I want these units in radians because that's what you need to be able to use them in other parts of the formula. 25 pi over 4 radians per minute. Okay, then when you get to horse B, again, you will use R times W for the linear speed. The thing is that your radius is no longer 25 feet. Your horse B is sitting at 2/3 of that radius, sitting at 2/3 of the radius. So you'll go like this. You'll go 2/3 of, so multiply, 25 feet. Okay, that's my radius. So 2/3 of my radius times my angular speed, which is 25 pi over 4 radians per minute. Okay, so to get an exact answer on my calculator, I'm going to ignore the pi, and I'm going to multiply everything on the top, and I'm going to divide everything on the bottom. So I will take 2 times 25 times 25, divide by 3, divide by 4, and hit math, enter, enter. and then throw the pi back in there. Okay? And when you do that, you should end up with 625 pi over 6 feet per minute. And again, if you want a decimal answer, that's fine. You can get a decimal answer by going 2 times 25 times 25 times pi, dividing by 3, dividing by 4. That will give you a decimal answer. I don't know what it is right now because I don't have my calculator, but that's what you would do. Okay? So that's how that should work. Again, radians are magical. That unit will disappear. So when you're finding linear speed, it should be in feet per minute. You don't need the radians in there. Okay? Then, it doesn't ask for this in the problem, but I just want to show you this really quick because you're going to have to do this a lot. If I had asked you for, let's say, horse B's linear speed, I'm going to just do this off to the side here. Horse B's linear speed. What if I had asked you that instead of in feet per minute, if I had asked you to put it in miles per hour for me? Okay, so I'm going to take you to that and just have you practice some converting so that we can use it for the next problem. If I'm at 625 pi over 6, and right now I'm in feet per minute. Okay, again, a little chemistry lesson. So, first of all, I have to go from feet to miles. And you need to know this. You might want to write this on the top of your paper because you're going to need to know it a lot. There are 5,280 feet in 1 mile. Okay, there's 5,280 feet in 1 mile. Obviously, one of those pieces is going to go on the top. One of those pieces is going to go on the bottom of a fraction. I want feet kitty corner from feet, so I'm going to put the 5,280 feet on the bottom and the 1 mile on the top. When I do that, the feet will cancel each other out. Okay, so if I were to multiply this out right now, I would be in miles per minute. Okay, that's what my units would be in. So I've got the miles part of it, but now I need the hours. Okay, and what I know kind of off to the side is that 60 minutes is the same as 1 hour. Well, one of those will go on the top, one of those will go on the bottom. Right now I have minutes on the bottom, so when I write my conversion, I need minutes on top. So I'll put 60 minutes on the top and 1 hour on the bottom. Okay, and then my minutes will cancel. And I will stick this into my calculator and I will ignore the pi right now, and then I have to throw the pi back in. So on my calculator, I will take 625 times 60 divided by 6 divided by 5,280, okay, and then throw the pi back in. And actually, I only have this answer in a decimal form right now, but if I take 625 times pi times 60 divided by 6 divided by 5,280, you should get about 3.72 miles per hour. So that carousel is moving really, really slow, okay? All right, moving on to the next problem. This is talking about the diameter of a wheel. Okay, again, when you do circular motion problems, there's always 3 parts to it. V, R, and W. And you will know 2 of those 3 parts, and you will need to find the 3rd part. Okay, so it gives me some hints in there. The diameter of the bicycle wheel is 26 inches. Well, if I know the diameter, I can cut it in half and find the radius. So this we know is 13 inches. That's fabulous. Okay, traveling at a speed of 35 miles per hour. So I know that that's either my angular speed or my linear speed. It doesn't tell me what, so I need to think. It gives me in a distance per time, a miles per hour kind of time. So if it's miles per hour kind of time, that means that it is linear speed. So that is 35 miles per hour. Okay? So now, this is what I want you to notice. I'm going to write this down here kind of out of the way, which you can do too, because you'll see why I'm having to do this. Okay? We know that V equals R times W. And so if I'm wanting to find W, then W is V over R. I think that makes sense. Hopefully it makes sense too. Okay, and here's the problem. Your V right now is in 35 miles per hour, and your R is in 13 inches. So I don't know if you can see this, but we have a problem. We have miles here, and we have inches here, and that can't happen. They have to be the same unit, okay? So one of those is going to have to be converted. And it doesn't really matter which one. You can convert the inches to miles if you want, or you can convert the miles to inches if you want. But I'm going to have you read the question because in the end it's asking me through how many revolutions per minute. Okay? So this is what I would suggest doing. I would suggest taking that miles and converting it to inches so that I have the same units top and bottom. And then while I'm at it, as long as I'm converting the miles, I might as well convert the hours right here to minutes. Okay? I'm going to convert the hours to minutes. So I'm going to leave this for right now because this isn't going to work. But I'm going to come back up here and I'm going to convert then that 35 miles an hour. I'm going to convert to inches so that it's the same as the radius, and then I'm going to convert the hours to minutes while I'm at it so that I have it in the right unit. Okay? So, in 1 mile, there are 5,280 feet. Okay, notice how I have miles, kitty corner from miles, so that they drop out. If I were to give an answer right now, I'd be in feet per hour, and that's not going to work. So I need to convert those feet to inches. So I know that in 1 foot, there's 12 inches, and the feet need to be kitty corner from each other. So in 1 foot, there's 12 inches. Feet kitty corner from feet so that they drop out. So these will drop out now. If I were to give an answer right now, I would be in inches per hour, and that's not going to work. It would work, but I needed my answer in minutes anyways. So I'm going to convert that hour. I've got the inches now. That's fabulous. I'm going to convert that hour to minutes. And I know that in 1 hour, there's 60 minutes. The 1 hour has to go on top, and the 60 minutes to go on the bottom, so that I have an hour on top and an hour on the bottom to cancel, like here. Okay. Then I am going to multiply that out. And again, anything on the top I multiply, anything on the bottom I divide. So I'll take 35 times 5,280 times 12, divide by 60. And when I do that, I should get 36,960 inches per minute. Okay? All I've done is convert my linear speed now. That's all I've done. I have not found my angular speed yet, but that is my conversion of my linear speed. Okay, so now what I will do is I will go back down here, and this now is my converted linear speed. So that would be 36,960 inches per minute over my radius, which is 13 inches. Okay. When I do that, I should get 2,843.08. What happens is my inches drop out. And now think about this. I'm finding angular speed. Speed is always in something per time. So clearly my time is minutes. Okay. And my something, I don't have a unit there. And my magical units is radians. And again, whenever you're using this formula, it's assumed that your angular speed is in radians, so it's the natural thing to put there. Okay? So now, it seems like I've got it done. I've got my angular speed. It's 2,843.08 radians per minute. But if you go back and read the question, what I wanted you to find is I wanted you to find it in revolutions per minute. Okay? In revolutions per minute. So I now need to convert that radians to revolutions. And what I know is that 1 trip around the circle, which is 1 revolution, is 2 pi radians. I need the radians to be on the bottom so that they're kitty corner from each other, and the 1 revolution on the top. Okay? This is big, big caution to you, and that is this. When you divide by the 2 pi, you're wanting to divide by the quantity 2 pi. When you divide by that quantity, the 2 pi has to be in parentheses or your calculator will not do the order of operations correctly. So when you put that in, put in 2,843.08 divided by parentheses 2 pi. Okay? The radians are going to cancel, and you will be in revolutions per minute, which is about 452.49 revolutions per minute. That bike is going crazy fast, like Lance Armstrong or faster fast. Probably a little unrealistic, but I'm sure there's people that could do that. So that is circular motion in a nutshell. You will need some practice on this. I know that. And so we will do that in class. See you next time.